Good morning all. Myself Ravi Sharma from the PG Department of Chemistry, DAV College, Amritsar. I am going to start with the very important topic in chemistry, in organic chemistry, that is reactions in organic chemistry. There are series of reactions in organic chemistry. These are all naming reactions. We want to go into the application of all these reactions. We want to go for their mechanisms so that there are large number of conversions which are being asked in the exams. So once you know the mechanism of this reaction, you can easily go for the conversions and the other questions which are dealt with this. So there are naming reactions in chemistry. I start with the first reaction, that is Aldol condensation. So I will first define the reaction, I will give its mechanism, and we will go into the details application of this reaction. So it will be a series of lectures because there are large number of naming reactions. So I will be covering these reactions one by one. My first reaction is Aldol condensation. It is basically a reaction which starts from +2, that is aldehyde and ketones, nucleophilic addition. And it is covered in BSc as well as in post-graduation classes. So first I define what is Aldol condensation. The definition of this definition says two molecules of aldehyde or ketone, two molecules of aldehyde or ketone, one of which have at least one alpha hydrogen. This is the condition. This is the condition for this reaction to occur. Two molecules of aldehyde or ketone, one of which must have at least one alpha hydrogen, in presence of base, condense to form beta hydroxy aldehyde or beta hydroxy ketone. The definition says two molecules of aldehyde or ketone, one of which must have at least one alpha H. This is the condition. In presence of base, condense to form beta hydroxy aldehyde or beta hydroxy ketone, which on heating forms alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. The definition says two molecules of aldehyde or ketone, one of which must have at least one alpha hydrogen in presence of base, condense to form beta hydroxy aldehyde or beta hydroxy ketone. This beta hydroxy aldehyde is also named as aldol. From its name, it is named as Aldol condensation. Aldehyde, ol means alcohol, beta hydroxy aldehyde, it is called aldol, to form alpha beta unsaturated carbonyl compound. So I take an example of this. Two molecules of aldehyde, I take an example of acetaldehyde. These are two molecules of acetaldehyde. In presence of, you take a base I am taking is dilute NaOH. So when you start with this reaction, this is IUPAC name is ethanol, and its common name is acetaldehyde. So what we say, two molecules of acetaldehyde, this is my first example. Two molecules of acetaldehyde in presence of dilute NaOH, they condense to form beta hydroxyaldehyde, but this molecule, at least one of them, should have an alpha H. Now what is the alpha H? Alpha H is functional group. This is carbonyl group. The carbon adjacent to the functional group. Carbon adjacent to the functional group is called alpha carbon. The hydrogen which is attached to this alpha carbon is called alpha hydrogen. Now this molecule, this also has condition is one of them must have a alpha hydrogen, but in this case both the molecules have a alpha hydrogen. So we require at least one of them, but in this case it is both the molecules are having the alpha hydrogen. When both the molecules are same, this reaction is also called self-condensation. So this is self-Aldol condensation. This is self-Aldol condensation, when both the molecules are same. What will actually happen is, I will go into the details of the mechanism, but prior to it, just a simplified form, this H is positive, carbon is negative. Oxygen being more electronegative is negative, carbon is positive. I will go into detailed mechanism, but just a simplification of this. This positive goes to negative and this negative goes to positive. That is, two molecules have joined together, that is condensed. What will happen when these two molecules will condense? When these two molecules will condense, they will form a molecule that is alpha, beta. This is beta hydroxy aldehyde. This is beta hydroxy aldehyde. So two molecules of aldehyde, at least having one alpha H, in presence of base, they combine, they condense to form beta hydroxy aldehyde. What's its IUPAC name? 1, 2, 3. 3-hydroxy butanol. 3-hydroxy butanol. Now it has a aldehyde group. Yes. It has a OH group. Yes. Therefore it is also named as aldol. So this aldol comes from the compound which is formed after condensation of these two molecules. Now on heating, when you heat it, this will undergo dehydration. Dehydration is removal of water molecule. Water will be removed from, hydrogen will be removed from the alpha position. OH will be removed from the beta position. That is removal of H and OH. This is dehydration. On dehydration, it results to form alpha beta unsaturated carbonyl compound. This is but 1, 2, 3, 4. But-2-enol. It is alpha beta unsaturated carbonyl compound. Now this definition is complete along with the example. Two molecules of aldehyde, one of which must have a alpha hydrogen, in presence of base, condense to form beta hydroxy aldehyde or beta hydroxy ketone. If I take an example of ketone, I am taking example of aldehyde. On heating, this will undergo dehydration. Dehydration is removal of water to form but-2-enol. Now this but-2-enol is basically crotonaldehyde. This is crotonaldehyde. Now what is aldol condensation? I have explained this with an example. That is, two molecules of aldehyde in presence of dilute NaOH, they form beta hydroxy aldehyde, which on heating undergoes dehydration to form but-2-enol. That is, reaction with its definition, it has been completed. Now if you want to go, there are large number of reactions. How many reactions can we study? We basically want mechanism of this reaction. Once we know the mechanism, all these reactions will immediately be converted. So if I take another example, suppose if I take an example of acetone. This is two molecules of acetone. There are large number of reactions. How many reactions can we study? So better way is to study these reactions. First we should know the mechanism. Once you know the mechanism, all these reactions definitely will be quite easy to study. So we take an example of acetone now. This is two molecules of acetone. Same, if the two molecules are same, it is called self-condensation. This is again alpha H. It has a alpha H, yes. Now this is carbonyl compound. Carbon adjacent to the carbonyl group is called alpha carbon. This H is called alpha hydrogen. Simplified form again I am saying, This is positive, this is negative. This positive part goes to negative क्योंकि oxygen is electronegative, carbon is positive, H is positive, C is negative. So this basically is a condensation. So two molecules of aldehyde, they basically combine to form beta hydroxy ketone. This is alpha, this is beta hydroxy ketone, which on heating undergoes dehydration. Same concept. Large number of reactions can be written, but they basically follow the same mechanism. I'm starting with the mechanism, but before that, a simplified concept just to introduce this topic. Now this is my alpha H, this is my beta H. Removal of water molecules from alpha and beta positions to form the product. Now this is my product. So what is aldol condensation? So we are basically moving into the concept of aldol condensation, taking these two examples. Now this is a very important compound. In your lower classes, you will basically get the questions, write a note on aldol condensation, or the smart way will be conversion of this compound. So how it can be asked in the exams? Convert ethanol to crotonaldehyde. This can be a conversion. Acetone to, now this compound with its IUPAC name says 1, 2, 3, 4, 5. 4-methyl pent 3-ene 2-one. Now this compound is called, very important compound, macetyl oxide. Now what is this aldol condensation? I have explained the definition to you. I have given two examples. Now I will be starting with the mechanism of this reaction. So what is aldol condensation? I have explained two molecules of aldehyde or ketone in presence of dilute NaOH, they condense to form beta hydroxyaldehyde or beta hydroxy ketone, which on heating they form alpha beta unsaturated aldehyde or alpha beta unsaturated ketone. The question that can be asked is, convert ethanol to crotonaldehyde, convert acetone to macetyl oxide. Now mechanism of this reaction. So what is the detailed mechanism of this reaction? So I start with this. So once you know the mechanism, you can relate lot number of questions on this basis. First point that you must know is, it is base catalyzed. It is a base catalyzed. Another option is it can also be acid catalyzed. But first of all, I will be going for base catalyzed condensation reaction. It is a base catalyzed condensation reaction. First point that must be known to you is, it is a base catalyzed condensation reaction. In the other part, I will be explaining acid catalyzed also. But maximum cases we are dealing it with it is base catalyzed condensation reaction. Second, it is nucleophilic addition reaction. It is a nucleophilic addition reaction. So, third point it can be, it occurs in presence of, it requires presence of alpha H in the molecule. It requires presence of alpha H in a molecule. Now question is, why we require alpha H in a molecule? Because alpha H is basically a acidic hydrogen to create a acidic center. Now what happens is, if I explain these 3 points by taking this example, again I have to take the same example, but now I am taking it with a mechanism. So what will happen actually is, complete the following reaction taking its mechanism. Now I will be completing the same reaction, but I will be dealing it with the mechanism. So once you know one mechanism, large number of reactions can be framed. So first step, First step involves abstraction. Abstraction means removal. Abstraction of alpha H by the base to form abstraction of alpha H by the base to form carbanion. Now this is your first step. Abstraction of alpha H by the base to form carbanion. What does it mean? This is my carbonyl compound and this is my alpha H. Now this alpha H is slightly acidic. How it is acidic? If I take a base, say it is OH negative, dilute NaOH, there will be abstraction, means there will be removal of H positive ions. H positive ions will be removed. Now what will happen? When H positive ion will be removed, carbon will acquire negative charge. Now negative charge on the carbon, it is basically called carbanion. Negative charge on carbon is called carbanion. Now this carbanion is resonance stabilized. This carbanion is resonance stabilized, that is the lone pair of electrons in conjugation with the carbonyl group, they undergo resonance to form. This is my resonance stabilized carbanion. This is my resonance stabilized carbanion. So this is the resonance hybrid. So first step is you create a alpha, remove the alpha H by the base. This H is slightly ionizable. It is acidic because the carbanion which is formed after its removal is stabilized due to resonance. Since it is stabilized due to resonance, therefore this can easily be removed. We require a weak base. In presence of weak base, there is abstraction of this proton, abstraction of this hydrogen actually, to form a carbanion. This carbanion is stabilized due to resonance, and this is the resonance hybrid. This is the resonance hybrid. So in the second step is nucleophilic addition. Second step is nucleophilic addition. And it is actually a slow step. Every reaction is controlled by a rate determining step. So this is slow rate determining step. What will happen is nucleophilic addition means attack of carbanion which is now behaving as a nucleophile. Attack of carbanion which will now behave as a nucleophile. So base catalyzed, I have explained it. It is a base catalyzed reaction, first point. Nucleophilic addition, now nucleophile has been created. So one molecule will remove the proton with H positive and it will form a carbanion. This carbanion will be behaving as my nucleophile, and attack of the nucleophile on carbonyl group of second molecule. Carbonyl group of second molecule. So there are actually two molecules participating in the reaction. In the first step, there is basically formation of a carbanion, and in the second step, this carbanion, it will be in the slow rate determining step. This carbanion will attack the carbonyl group to form a transition state, to form a tetrahedral transition state. This is a tetrahedral transition state. So this is your rate determining step, that is the slow step. Now there will be gaining of H positive ion from the solvent, to form this molecule. Now this molecule is your beta hydroxy aldehyde. This molecule is your beta hydroxyaldehyde. So I complete the mechanism of this reaction now. I have started with the first molecule. The first molecule is basically formed a carbanion. Now this carbanion will behave as my nucleophile. This has been formed in presence of base, therefore it is base catalyzed. I am concentrating myself on base catalyzed condensation. The first step involves the formation of a nucleophile. Yes. Nucleophile which has been formed, this will now attack in the second step to the other molecule of carbonyl compound. Therefore there occurs nucleophilic addition. There occurs nucleophilic addition. This is a tetrahedral transition state. Now it will gain a proton from the solvent to form the product, and this product is beta hydroxyaldehyde. This was your product. Now if I say what is this A, paper says complete the following reaction to form A. Now this A is my beta hydroxyaldehyde. This A is my beta hydroxyaldehyde. Now you basically go into the mechanism. First is removal of H positive ion to form your carbanion. This carbanion attacks on the second molecule of the carbonyl compound to form your tetrahedral transition state. Now there will be proton from the solvent to form beta hydroxy product. Once this beta hydroxy product is formed, now there will be removal of this beta hydroxy which is formed. There occurs dehydration. There occurs dehydration on heating to form alpha, and this is beta. So there is dehydrated product, that is alpha beta unsaturated carbonyl compound, which is my crotonaldehyde. So I think you got the mechanism of this concept. Take the first molecule, it should have a alpha H. This alpha H will be removed by the base to form your carbanion. This carbanion will be behaving as your nucleophile. Nucleophile attacks in the second step on the second molecule of carbonyl compound to form your addition product. This is nucleophilic addition. When the product is formed, that is beta hydroxyaldehyde, this product, it will be on heating undergoing dehydration to form a more stable product, that is alpha beta unsaturated carbonyl compound, and this compound is crotonaldehyde. So this is the first part of your concept. That is, I have just taken the example part and I have discussed the mechanism. Now the second part can be application of this. So that will be covered in the next video. I think you are able to relate to the concept, definition along with its example and the mechanism. The first part I have completed. The second part will be to detail applications of this concept that we can deal in the next lecture. Thank you.